taking a long time. Maybe they don't take a long time. My technology does. Okay, here we go. So we're going over the worksheet. Jonathan, you found it?
Yeah.
Cool, let's grade. Oh, wait a minute. When we're grading, what are we supposed to be using? Colored pen. Colored pen. Just in case you get something wrong. Maybe you don't. Maybe you ace it, but then you can give yourself 100% in the colored pen. All right, so for those of you just joining us, my recorder got funny, but we're going over our worksheet, and then we're going back into our notes. We were looking at this guy, and we said, that jump's really hard. This jump looks a lot easier. What could I multiply -2 by to get 18? Yeah, but -9, right? Did you guys double check that? Does that keep working as you go to the next jump? Good. Good, good, good. Ooh. The pattern is that the decimal place is moving 1 to the right every time, right? How or what makes the decimal point move 1 to the right? When I multiply by 10. Good. That's a hard one. When I multiply by 10. Because we're trying to find the common ratios, and so if you guys haven't realized yet, what we've been doing by finding the multiplication jumps are those common ratios, right? So this one was a little bit harder, but it should have been -1/2, because I would have needed to do a negative to make the signs flip, and I would have needed the 1/2 to go from 2 to 4 to 8 to 16. And then this one, I believe, double check me. Did you guys find it was 3? Nice. So then moving on down to the next section. How did the directions change? How did the directions change in the next section? Oh, so we're supposed to continue the sequence, right? Jonathan, focus. So continue the sequence. Hopefully you guys realize you were dividing by 4. So what happens when we divide 3 by 4? Oh, gross. Okay, 0.75, but did you guys realize over here in the answer options, I think they were using fractions for some and decimals for others. So I'm going to come back up here, and I think it's a lot easier to not even have to go to your calculator to do 3/4. Because then you could go ahead and divide by 4 again to get 3/16, and divide by 4 again to get 3/64. Some of you use your calculator so much that you make your life hard. Because if you noticed it was dividing by 4 or times 1/4, I could just say times 1/4, times 1/4, times 1/4. I didn't have to go to my calculator once. Now this one for number 8, you're not going times 1/4 anymore. Now you're just going times 2, right? So what you guys get after 96? It was 48, 96, and then 192, and then 384. Good. Rocked it. But what was your pattern for number 9? Oh, yeah, the decimals. Going the other way, 110 is going to move it, and then the negative is going to flip-flop my signs like I want. So then couldn't I wouldn't go to fractions on this one. I think I would just keep on moving my decimal place, right? To -0.01. What's the next one after that? Yeah, there's positive, and then we would go, the last one would be another negative, right? 0, 0, 0. Whew, just keeps going. This pattern, I think I'm dividing by 5 again, yeah? But why is it not a -5? There are negatives. Why is it not a negative division by? Yeah, a negative times a negative would be a positive, and that's not happening. So I must just be keeping the negative every time. And if you guys notice, this is another one where doing decimals would have been so much worse. Because I didn't have to use my calculator once. Because I noticed my R was 1/5. So I just had to say times a fifth, times a fifth, times a fifth. Once again, decimals aren't always better. Okay, then it got a little bit nastier down here in 11 through 14. But guys, I think we have enough at least for part of our message. So if you guys had filled in just 1 through 10, how much of a message did you get? Or actually, what is the message? You guys figured it out? Maybe some of you. It flipped? Oh, got it. With. That makes sense, I suppose, huh? It's a pancake flipper. Anyway, that means that number 11 needs to be R. Number 12 needs to be F, right? Because maybe you figured it out. I actually heard 1 or 2 of you that I think might have gotten it before you even started the worksheet. So here's a quick word to the wise, was the point of the worksheet getting with its flippers as a little silly joke? No, not at all, right? So even if you got with its flippers, I mean, that's great and all, but you didn't do the homework unless you actually solved. So we know that 11, 12, 13, and 14 need to be R and F and I and P. We can go find the answers. But the point was, if you could actually do it. So this says write an equation for the nth term and then find a sub 6. Did any of you guys realize that over here in the answers, it was really just a sub 6? So technically, couldn't you have just filled in one blank? Did anybody figure this out? I mean, it could have been really strategic because look at your answers. Aren't the answers just this guy? So couldn't you have just found your pattern and said times 4, times 4, times 4, and just gone times, let's see, 1, 2, 3. Because what does this stand for? Oh, so wait, 1, 2, 3, 4. I couldn't take that one. I'd have to go one more. But couldn't I just go 2 jumps and I would be there? Yeah. Now, I'm not saying that's what the problem was asking, because technically it wasn't, but it would be kind of strategic, and it would show that you understand what's going on if you had realized, oh, I just need to do 2 more jumps, and I have my answer without even finding my equation. It would mean that you understood it, and you were being kind of strategic, maybe in a little bit of a not following all the directions kind of way. It says to make the nth term equation, because you're supposed to be practicing that. But if you did just do 2 jumps, oh, hold on. What's 192 times 4? I don't have that one off the top of my head. 768. Yeah, nicely done. So I have to do 768 and do times 4 again, right? And that would be 3,072. So you could have actually gotten to that final answer, guys. Well, hold on. This one has 1, 2, 3, 4, 5. Oh, I'd have to do 2 jumps for that one. I have to do 2 jumps for that one. I have to do 2 jumps for that one. But I could have actually just done 2 jumps for all of them and just taken that second jump. So this one I was dividing by a -4, so that would have been a -1 and then a +1/4 for the a sub 6 to get to that p. This guy, what were you doing? Dividing by 2? I think. So that'd be 0.18 and that'd be 0.09. Double check and see if I'm getting my RFIP right, but I think I am. And then times 1, no, times 3, times 3, times 3, times 3, and times 3. So it would have been good to go ahead and get the nth term. Of course. You would have been reviewing the homework and all the stuff that we did yesterday. But every now and then, if you understand the math, you can kind of do strategic shortcuts that make your life a little bit easier. And number 15 is a word problem that it was one of those you would have needed to finish that off, but most of you would have gotten your message before that. And so I'm not sure if we're going to necessarily take a lot of class time on word problems, because if you guys realize, at least right now, we're not really doing word problems in our quizzes or in our tests. Not right now. Nothing we never will. Not right now. Okay, with that, I do want to come around and grade homework, but let's just this one together. Can you guys just hold it up for me? Let's just do a hold up check real quick. Do you guys have any late work or missing work? Remember, you can always come in. Yeah. Oh, see. That one. As soon as I see it, put that worksheet away. As soon as I see that, put the worksheet away. Does that make sense? All right, worksheets away. Good job, everybody. So only Andrew ended up being absent today. The rest of you guys just came in late. Oh, no. Oh, my goodness. So Hannah came in, and then Adrian came back, and then Andrew's still gone. All right, guys, notes open. Yeah. Yeah, it's homework 7, right?
Yeah.
Okay.
I think this is the one where I showed you the nutrition.
Yeah, and I probably didn't write it down. Sorry about that, but sometimes I get distracted and I don't get to finish. What's this? Worksheet. Put it away. Remember? And just put away the worksheet as soon as that happens. Here we go. Nose open. Turn back on the light. Some of us are getting a little tired. I know I am. It's warm in here. Melanie, did you have a question? Yeah, I'm actually going to announce that. I was going to do the end of class. Hey guys, can you look at your board really quickly? Melanie brought up a great question. The corrections. You guys remember that we got out our old test on Friday? We were working together. It was a minimum day, so we didn't have a lot of time. We were working on test corrections. And then it was supposed to be homework for the weekend, and I said, hey, if you want to end by the end of the grading period to get some extra points, which 3 of you did. 3 of you did. You got your corrections done early. And so you turned it in Monday or even yesterday, and then I got some points back. But the rest of you guys, it's actually been on your board, but maybe you haven't paid attention. When are the corrections due for everybody? Friday. So on Friday, it's an assignment. It's actually worth 10 points, which is worth like 5 homeworks. It's due on Friday to be completed, and then I will still get you points back. It wasn't in time for the grading period today, but it'll still get you some points back. Now, how many points back? Well, I go through your corrections, and I see if you were able to not just have the right answer, because I wrote the right answer. I wanted you to know what it should have been. But not just that you have the right answer, but you have the work to show me why. And isn't there a box that says, like, explain what went wrong? Or explain how to do it right if you don't know what went wrong? So there's a little explain. You have to put, like, a sentence or so in there. And then show me the right work. But if you do that, and if you do it in a way where I'm like, oh, this shows that they know how to do it now. On this one, the very first test, I'm giving you half points back. Now, the next test will only be a third points back. The next test, a fourth points back. The next test, a fifth points back. Why? Because as you get more used to me and my class and what the tests are, theoretically, and as you go through math, you're getting stronger, you're learning how to study better, you're coming in because you're feeling more comfortable to come in after school and ask questions. There's quite a few of you now coming in, we're doing whiteboard problems if you get stuck, etc. Some of you came in and asked me questions on test corrections, and so I helped you. But there's a lot of you that still need to finish those up. So, yeah, totally fine to turn them in, and Friday is the due date for everybody. Okay, so if you guys need to, write it down in your planner. I don't think it's necessarily on RedWeb specifically, but I'll make sure I put it on RedWeb. It's just been something that's been on the whiteboard all week. So, Monday was for getting it in, and even yesterday I took one more, was for getting it in by the end of the grading period. But on Friday, it's going to be a 0 if you don't turn it in, and then it's going to be late work if you turn it in later. So, what's due on Friday? Test corrections. But you can come in after school, today or tomorrow, or even on Friday. I'll say Friday by the end of the day. Some of you guys have like sports practices during 7th period, and maybe you have a study hall sometimes. That's my prep period. Come in, we'll work on your test corrections. I don't mind. Or maybe you have practice and well, I don't get out till 4 or 4:30. I'm usually still here. Now, just a few of you, I think practice goes later, so maybe it's asking your coach if you can come right at the beginning of 7th period or something like that, or right at the beginning of practice. And then for my non-athletes, maybe you have carpool, maybe you have other things, I'm usually in here during lunchtime. You just need to ask me. You don't just assume I'm here. Because if you're like, well, I stopped by and you weren't there, but if you didn't ask me, I'm allowed to be present. You know what I mean? So, does that make sense? If you guys have questions, if you're stuck, you're not alone, you can come ask. But we actually need to do 6.7, at least start it today so that you guys can rock out on your homework tonight. So we're going back into the book. Now, it's weird because usually after every section, haven't we had a quiz pretty much right away?
Friday.
But this one, we're kind of in a rhythm. We're doing a lot better. You guys know to open up your notes or your homework spirals. You know kind of how we're doing a bookwork worksheet. So we finished earlier in the week. So we're moving on to the next section. The quiz isn't until Friday. So the quiz will have a little bit of 6-7 and 6-6 on it, but we'll review tomorrow. Okay, here we go. 6-7. Recursively, it sounds awful. Recursively defined sequences. Don't worry, it's not that. Recursively defined sequences. Use the previous term to find the next term. Wait a minute. Isn't that what we were, guys in the back? This is my focus. Weren't we doing that here? Hold on, did you guys read the notes that you took today? Recursively, or recursive rule. Use the previous term. Okay, we know what terms are, right? Terms are the like, hey, it's the first guy, and then there's the second guy, and then there's the third guy. I'm using letters because the numbers always change. Yeah? But we have the first guy, second guy, third guy. This is the position. Use the previous term to get the next one. What did we do on this entire worksheet to fill in blanks? Yeah, we found the pattern. We're like, sweet. There you go. We did the jump. We did the pattern. We did the multiply. We did the divide. We did the pattern. That's exactly what this section is talking about. It's just a little bit different than these types of problems. Because in these types of problems, I know that this asked for a sub 6 or the sixth term. So I was like, hey, you could have figured out the pattern and gone like boop, boop, and 2 jumps, 2 multiplications, and you're there. But what if they asked for a sub 20? And think about it. What if it was a sub 20? Which term is that? The 20th? Do we really want to like 20 times? Or it would only be like 14 times. Would we really want to do that? No. So what would have been a better way if in the worksheet it didn't ask for it? This was the easiest way for these problems to solve. But what if it didn't ask for that? What if it asked for a sub 20? Wouldn't we have wanted, like for number 11, wouldn't we have wanted that equation where it says give me any n and I'll get you an answer? Because in this equation we would have taken, do you guys remember what fills the first box? Isn't the first term the first box, right? Do you remember what goes next? The different, well, in this one it's the ratio. The ratio. And so what was the ratio? Times 4. And then don't we do the n minus 1 up there, right? So if I want 20, I don't have to do, yes, you're welcome, Julie. I don't have to do that, because he was laughing all my time.
Oh, I was laughing at Sean.
Poor Sean.
Poor Sean.
Hey, you guys shouldn't have talked to anyone. We're coming back.
Stop bullying the trees.
Oh, calm down. But if it's a sub 20, I wouldn't have to do all of my jumps. Instead, I would just plug in my 20 and I plug in my 20 and I'd be done. Well, I wouldn't be done, but I could go ahead and just say, hey, I'm jumping straight there, right? Here's what's different in these ones, the recursive sequences. Recursive sequences say, we don't do the whole a sub n and go straight to the 20th, or straight to the 100th, or straight to the 7th, or straight to the 13th. Instead, this one says we only do the jumps. So let's try to summarize that in a little line that we can remember. Geometric sequences. In section 6.6, we had a nifty formula that let us jump to a position. This one says we always have to use the previous to find the next. So the goal is find and continue the pattern. This one's not going to be as nice. It's not necessarily going to be as pretty. We're just trying to find the pattern and then continue it. But the equation's going to be a little bit harder. So, recursive rules. What we need to do is find a pattern and then continue it. And some of you guys are great at patterns. Some of you it's a little bit harder, and that's okay. We'll work together. But we're trying to find and continue the patterns. Now we got it. We're just in section 6.7. We just started a new page of notes. We graded the worksheet at the beginning. Find and continue the pattern. Okay, so let me show you guys what the formula is, though, because the formula does look weird. I don't want you guys to get all confused. But can we remind ourselves of something real fast before we do the formula? Doesn't N stand for position? Right? Just a quick reminder. N stands for position because when we were looking at the worksheet, and Armando, you missed this. Armando, you missed it, but it's okay. We can review right now. We were reviewing in homework how on this section it asked for a sub 6. And we were reminding ourselves about how a sub 6 is the sixth one. It's the sixth one in the term. So remember that n guy, it's the position, it's where it falls. That's super important for us learning this formula. So here we go. Ready? Let's see if you can read the formula. Because sometimes it's much easier if you look at a formula and you can make a sentence that kind of means the same thing. Like, area of a square is side times side or side squared. Like, oh, there's a square and it has sides. And then you can make a sentence from a formula that makes more sense. So check it out. A sub n is equal to, if I can get it, hold on. A sub 1 there are a lot of different recursive rules. Sorry guys, my pre-calculus stuff is having me remember the harder one. I don't want to remember the harder one, I want to remember the easier one. Okay. To be totally honest, this isn't completely new. They look kind of new, they look kind of weird. They don't look exactly like the other ones that we've seen. Let me move these guys down because they're kind of in our way right now. Let's remind ourselves of who the different players are in this formula. So we have a sub n, which we already learned is the nth term, right? The guy that's in the nth position. The nth term, the guy in the nth position. Do you guys remember who a sub 1 is? The first term. And we used that in the old way of defining. But here's the really weird guy. He's the new kid on the block. This a sub n minus 1. We've already talked about the nth term, already talked about the first term, but who's the a sub n minus 1? He's the previous. He's the previous term. Remember how I was talking about how we filled in the blanks, and when we filled in the blanks, we jump from one term to the next, to the next, to the next. A sub n minus 1 just says, well, wherever you want to be, it's the guy who came before. Wherever you want to get, it's the one who came before. Now, for some of you, just be really, really careful because the n minus 1, as soon as it starts getting longer, more complicated, you forget it's in the subscript. It's down below the a. Just like an exponent is above the a, n minus 1 is below the a. It's like a part of his name. So this whole thing is the previous term. It's one box. That's it. Just one box that we're trying to fill. So he's the new guy. Our goal. Find and continue a pattern. For a recursive rule, we say to get that nth term, whatever the pattern is, we do it to the previous term. So let me give you a couple examples from section 6.6. Let me dual page it over. So examples. What if we were trying to write or make a recursive, that's the snazzy new term. Now, actually, guys, in programming, in computer programming, computers work way faster than human brains. The human brains have to give the computers or make the computers programs in order to tell them how to operate. This thing called recursive rules is actually super important for computer programming because you're telling a computer, hey, do this and then this and then this and this, which for a human, it's like, I don't want to go through all those steps. I want a shortcut to skip to the end. But for a computer, it's like, oh, you can work fast. Don't worry about it. Just go this way. Recursive programming is actually a thing. But don't worry, we're not doing computer programming today. It'd be cool if we could. But we're just going to talk about the foundation of this idea, recursive, by taking a sequence. Like, I don't know, how about, give me some random starting number. Go for it. 30. So if I was to start with, let's do problem number 1. Start with 30. And then if I was to go ahead and have the next term be something like, I don't know, how about negative 10? Then the next term was something like 10 thirds. And then dot, dot, dot. Let's see if you guys found the pattern. What's the pattern? Yeah. But careful, not a positive 1/3, right? A negative 1/3. So the first thing that we need to do when given a sequence is to find a pattern, which is very similar to the last section. Find a pattern and it's times negative 1/3 times negative 1/3. Here's what's new. It's how we write the rule. If you're dealing with a computer, you don't have to tell it how to jump to the 20th or the 50th with an a sub n formula. You can just say, hey, just take the guy before, take the guy before, take the guy before. What I mean by that is, look, to make our rule, we would say, write the a sub n to get that formula. Write down the previous term. Take the previous term. Well, let me write it in the order that's over here. And which one makes more sense, guys, for this one? Would it be times r or plus d? Which one makes more sense? Yeah. So we would do times, and who is your r? Negative 1/3. So the rule would be, to make it look all nice and pretty, a sub n is equal to negative 1/3 times a sub n minus 1. That is the rule. You could tell a computer this and just say, oh, you know what, just keep multiplying by negative 1/3 over and over and over and over and over and over. See it? However, here's the problem. Maybe it's not enough just to tell it how to jump. Maybe it's not enough just to tell it how to jump. Because let's say it's told the computer, yeah, multiply by negative 1/3 over and over and over again. It's like, okay, sweet, so I'm going to start at 100 and times negative 1/3 is going to be negative 100 over 3. Is that going to be this sequence? No. What did you notice that I changed, that the computer might change, or that a person might change? Because it wasn't written down. The computer said, I'll just start at 100. But where do I need it to start at? Yeah. So the same way that Trey gave me my 30, I need to give whoever's looking at my problem, not just a sub. Did you guys notice that we only used 2 of these guys? Who are we missing? The first term. Whenever we have a recursive rule, we don't just need to know what the jumps are, we also need what to start. We need a sub 1. We need to know where to start. So whenever we have a rule, actually this isn't enough. This shows me the pattern. It doesn't show me where to start. So I would actually erase this. It was good work. I'm still going to use it. But I'm going to say a sub n is equal to negative 1/3 a sub n minus 1. I'm going to put a comma, and I'm going to say where or for a sub 1 is equal to 30. This one has my whole sequence. I have to tell it where to start and the pattern. So if you guys are one of those like colored pen sort of people, highlighting sort of people, if I were you, this guy, the a sub n, shows you the pattern. That's what this guy is for. Here's the pattern. You get to the next term by multiplying the previous term by negative 1/3. That's what recursive does. It says you get to the next by using the previous and doing something to it. Sometimes you're adding, sometimes you're multiplying. This guy's the pattern, but this guy is the starting point. Is the starting term. You need both. You need both. If I were to tell you how to get to my house, and I said, oh, you know, just go about, how many miles is it? Yeah, go about 18 miles. Does that help you? You can get to my house, right? Go 18 miles.
No.
Because you need to know where to start from and what direction to go. So it's a little bit harder in real life than talking about that. But you need to know where to start from, and you need to know like what direction to head, right? Same thing here. We can know the pattern, but if we don't know the starting point, it's not enough. Now, some of you might be like, well, what on earth is homework going to look like? If we're talking about sequences still, if we're looking for patterns still, just the rules have kind of changed in how we write the rules. Let's see if, first of all, you guys can read the rules. Before we write the rules, let's see if you can read the rules. So what about if we give you something like this? This is where homework kind of starts. What if they don't make you write it, but they give it to you? Would you know what to do? First of all, who is everybody? Who's this guy?
The first term.
The first term.
Second.
And then?
The a n equals, oh, yeah.
Isn't that the next term?
Yeah.
So See, this is going to really help if you guys can figure out who's who. We have the first term, we have the next term, and who's this guy? Previous term. Okay, the nice thing is, anytime you have one of these, don't you already know exactly how to start? Starting's easy. Where would you start number 2? 0.7. We know the starting one just by looking at the first term, right? But the problem is we need to know how to keep going. So question, how am I knowing by looking at this formula that I'm going to have negative 8 next, and then negative 16, and then negative 24, and then, how do I know that? Starting here, to get to the next term, what do I do to the previous one? You want to draw a box. That's the previous term. What do I do to get to the next term? I have to take that previous term and... So we did that? Oh, that is all of it? And here, anyone say subtract 8. My formula, the recursively defined formula say to get to the next term. So back here, when I was still making it, I just gave you guys the answer and that was that on me. But to get to the next term, to fill this blank, I have to take the previous one. And then I say, oh, minus 8. Well, what's 0 minus 8, guys?
8.
Negative. Well, how do I get to the next term? Well, to get to the next term, I take the previous term and I do what again? Minus 8. What's negative 8 minus 8? How do I get to the next term? Take the previous one and subtract 8. Oh, okay, so then negative 24. Oh, I'm just subtracting 8. Negative 32. How many do I need? 1, 2, 3, 4, 5, 6. A negative 40. Good. Now it says to graph. We're going to do the exact same type of graphing as we did in the homework before. In that, remember, we graph the positions. First position, second position, third position. How many positions do I have? 1, 2, 3, 4, 5, 6. Uh-oh. I don't think this is a very smart graph for me, though, right? Because what are my terms doing? Yeah. I'm going to rewrite this. Sometimes you guys can be really strategic with your graphs, and I'm going to be strategic now. I'm going to go way down. There we go. 1, 2, 3, 4, 5, 6. Isaiah, I think it was you that said you were kind of just eyeballing it, right?
Yeah.
These ones are going to be kind of nice, though, because if you just go down 8, it's like, okay, I can make that 8 down. And then go down another 8. And another 8. And another 8. Oh, it's just like a line. I'm just going down 8. So maybe some of these won't be that bad. It's like, okay, we could eyeball it. That's not bad. Going down 8 and 8 and 8 and 8. I have to keep on going down 8s, but. So let's come look at another sequence and see if you guys can figure out what the next blank would be. Remember, we always have to start. Check. How do we get to the next blank? What does it tell me to do? To get to the next term, what do I do to the previous term? Use those boxes, it helps. I do have to multiply, not distribute though. What's the next term going to be? Who can see it? Which one, Caleb? Yeah, to get to the next term. Good. So to fill the blank, to get to the next term, what do I do? You have to read it as a sentence. What do I do to the previous term? Close. Ready? I'm going to write a sentence. To get to the next term, I need to do 10 times the previous term. Some of you guys are just getting overwhelmed by how yucky it looks, but check it. If that's next and if that's previous, to get to the next, I need to do 10 times the previous. Wait, who was the previous term? This guy. Yeah. So previous term is 0.7. What's 0.7 times 10? Yeah. Now, some of you, that decimal just messed you up. Now it's easy because to get to the next term, take the previous and do what? To get to the next term, take the previous and do what? Okay, now we're on a roll. Was the decimal just weird? Come on. Was the decimal just weird? And now it's going to be 7,000. And now it's 1, 2, 3, 4, 5, 6, 7,000. in the sentence over here. Maybe some of you guys, the sentence is a better idea. So you get to the next term. Or you can do the previous for this guy, for this statement, or this equation. What's the sentence say? To get to the next term, can't we just say previous minus 8? No, it's not super nice. In math, we don't usually say minus 8 anymore. We would probably say something like take away 8 from the previous, or subtract 8 from the previous. That sounds a little bit nicer. But guys, remember, every single recursive rule can be a sentence. To get to the next term, do what to the previous? Subtract 8, please. Okay. Minus 8, minus 8, minus 8, minus 8. Get to the next term, do what? Times 10, please. Okay, times 10, times 10, times 10, etc. Then you would graph it. That's where homework starts. Let's go peek at it, though, real quick and make sure that we're on the same page. So with homework, where does it start? Numbers 2 through 9?
Yeah.
And then 11 and 13 through 15? So let's check out. Number 2 is like a which one doesn't belong sort of thing. So let's not stress too much about him. But let's go peek at the through 9. How are we going to be able to start homework, guys, as far as when it asks us to determine whether it's, vocab. What's the difference between, Trey, this is your question. What's the difference between arithmetic and geometric? He's been rocking it. Arithmetic, remember what the pattern is?
Yeah,
Adding. And geometric is? Multiplying, right? Multiplying. It's okay, it's okay. So you guys help me out, because we still have a couple minutes left in class. I'm trying to help you out with homework. Can we look at each of these equations and try to figure out whether it's arithmetic or geometric? What do you see as far as number 3 sentence? What do you see as far as number 3 sentence? That's the starting point. Okay, cool. What's the sentence say? Put little boxes. Put little boxes wherever you see a sub n and a sub n minus 1. And what's his name? Next term. So to get to the next term, remember you can use my sentence. To get to the next term, who's this guy? Previous term. What's happening to the previous? If you need to, even put your hand and cover him up. I know it's nasty notation, just cover him up. His name is previous. To get to the next, what do we need to do to the previous? Multiply by 7. Multiply. Multiply by 7. Who is he? Arithmetic or geometric? Geometric. Yeah! He's geometric. Why? Because you're multiplying by 7. Right? So then take this statement. There's my starting. This guy's my next. This guy's my previous. What's the pattern? Adding 1. Do you see him? Right here. So this one was times 7 on the outside of previous. This one was plus 1, or adding 1 to the previous. So then it's going to be an arithmetic one because I'm adding 1. I have a common difference. So I'm adding 1. I could write words to that. I'm just doing it quick. So every time I'm adding 1. Now if we were actually doing something like down here where we were trying to write the sequence and graph it like our examples, this guy, I would need to start with 18, and how would I get to the next blank? What would I do to the previous? Add 1. Add 1. Add 1. Pause, sit. If I started at 2, how would I get to my next term for this one? So multiplying by 7, 14. Maybe 98. Alright, cool kids. Try homework tonight. Good for you tomorrow. See you soon. Next and previous. Next and previous. Don't get confused by how they look. One thing I come over here and show you though is when you're doing sequences, remember how these numbers stand for position, like the first, second, the third, right? For first and second and third. when we're doing this, we never connect the lines. Because if you connect, you say there's something between first and second. Like there's lots of points. No, it's just the first and the second. Does that make sense? Yeah, just keep it like that. Thanks, Gail. I'll come mark it down.